I'll note that at least one of your texts uses a time-honored method of reducing a problem to another problem to which there's a known solution, and that's worth mentioning. In this case, as we have already determined, we have a point on this line, a point on this line, and a line that's perpendicular to, or a vector that's perpendicular to both lines. So what we do with that is we take that vector that's mutually perpendicular and we find the equation of the plane through 2, 3, -1, which is the point P naught on the first line. And that equation is very easy to determine. We can simply read it off if we are familiar with the equation of a plane. And that's going to be 13 times x minus 2 minus 6 times y minus 3 plus 30 times z plus 1 equals 0. We don't really need the equation of the plane. We just need to know that it's perpendicular to this vector and goes through this point, but right there is its equation. And now all we have to do is find the distance of this point from this plane, because again this plane passes through this point and is perpendicular to this vector, so that this line lies in the plane, and the point at which to find the distance of a vector from the plane, what do we do? Of a point from a plane, we again project a line from a known point on the plane, known point being P naught and our point being Q naught. Project P naught, Q naught again onto 13i minus 6j plus 30k. This is simply another way of looking at the situation, of visualizing what's going on. Again, we project this vector onto the plane that passes through this point perpendicular to this vector.